Today we will be discussing about the HVDC transmission. What is your basic understanding of HVDC transmission, so that I can build on that? Can you just recount?
Basically, HVDC transmission is a one kind of transmission which is used to minimizing the losses
Minimizing the losses, okay.
of high voltage transmission system.
It is a corona effect and radio interference.
Yeah.
It is a corona effect and radio interference.
This is also a major part.
Reverses the corona and the radio.
Charging
current, ये तो उसका मतलब टेक्नोलॉजिकल होगा.
So,
But see the DC and AC. Why we had why did not have DC directly at the distribution level? Why that DC only for the transmission?
because it is possible, it is not possible to distribute level because we are
Why?
all applicants are using AC. We have
Because we have built AC.
और
अगर आप शुरू से ही डीसी मोटर बना लेते तो सही.
or another advantage, disadvantage of DC cannot transmit long distances because
DC cannot transmit long.
DC transmitted, but previous research because
Anyway, your knowledge is very preliminary. So, okay, we will start with this presentation. We will first go into the brief history. How we have developed, how we have come to this stage. Okay, history gives a lot of idea that how we have developed over a century or even more than a century. And why this DC has come up and why it was not there previously. So all those such questions are there. Then why HVDC for power transmission only? Then what is the basic configurations and the layouts used in the DC systems? Then we will discuss the power transmission and compare AC and HVDC both. And then we will see the latest technological developments in this area. So we'll start with the brief history. So it's good to know the history, how we have come to this stage. Do you know who invented the bulb?
Edison.
Thomas Alva Edison. When? 1800 and odd, 1880s. Okay. He was not only an inventor, he was a businessman. Thomas Alva Edison. He created a company called New York Light and Power Company in 1982 with this 110 volt DC, and he created generators and distributed to the New York City areas. Direct, no transmission, nothing. Generate and distribute. What was that? It was DC. It was DC power. And he was not selling the electricity. He was selling the light. If you have 5 bulbs, you will be paid for charge for 5 bulbs, 10 bulbs, 100 bulbs. And he will start in the night and switch off in the morning. So this is how he started. Transmission was not there. Then the French engineer René Curie, what was the problem with this system? Why it
Not step up or step down.
Step up, step down was not there. He has to generate at 110 volt and distribute at 110 volt. And if you take it to the long distance, then the voltage will
fall down.
fall down.
Or drop.
So there is a problem with this system.
Because any type of converter is not this system.
Yeah.
This is also a major issue in this time. But in this time, the converter with
Converter तो उस वक्त मैं
वही बोल रहा हूँ, converter नहीं था. But in this time, with the help of our electronic gadgets or device, we can implement in the HVDC system to long distance.
We will come to that. So this is how I am discussing the theory how we have started and grown to this stage. This French engineer wanted to step up the voltage so that he can reduce the losses. Come in. So this French engineer, he wanted to reduce the losses. How to step up? Not possible. What he did was that he connected the DC generators in series from the commutator to commutator. You know the DC generator, you must have heard. So there is a brushes on the top of the commutator. They give a plus and minus. So if you put them in series, 1 generator, 2 generator, 3 generators. So if you have a 110 volt and put 100 generators, then it will become 11 kV. So he achieved 125 kilovolt by 1912. It is possible, but it has a lot of operational problems because of the series connected generators with the brushes, which is mechanical, brushing on the commutator, sparking. So this system in fact did not work. Simultaneously, what happened? I'm just going, this is theory. Theory means the history. In 1895, AC system started, and this Michael Faraday, he came into the picture. He invented this electromagnetic induction. Induction is possible. Induction can do what?
Induce voltage.
It can create the induced voltage. It can make a transformer to step up and step down. You can create a DC AC motor, which is much simpler in construction in the comparison to DC motor. So this Westinghouse, in fact, started this AC system simultaneously in the city of New York. And this Edison, the inventor of the bulb, he became bankrupt. He has sell his company to Westinghouse. This is the history. So inventor can go bankrupt that way. So this could create transformation from one level to other level with the AC. So AC had biggest advantage. Convenient to control, simple in construction, brushless. There's no brushes required. But do you know these days you have got brushless DC motors also? BLDC motors. They have come. Fan has come. So it's a brushless DC motor, and that fan is preferred over this AC fan because it is no problem of reactive power. It is very efficient. It doesn't take much power. So DC is still having a lot of potential in the distribution. It's not that solar power is actually a DC power. Since we have got an existing system, which is the AC system. So if you have to integrate them, then you'll have to invert them and then connect. Yeah. Why?
Because DC is directly not connected to the AC without any converter.
That is why. That is what I'm saying.
But DC.
Why we are doing? Why can't we use directly? I have got a DC motor pump in my village. My father lives in a village. He is 95 years of age. He lives in village. When I asked him to come here, he says, "No, you are living at a wrong place. I am at the right place." He is having a DC motor. He got a solar pump, solar panels installed somewhere in 2004-2005. And that solar pump has directly connected to the DC motor without any inverter. And it can take the power from the underground and convert.
DC is another advantage. DC has the only resistance, Z is equals to R, but
एडवांटेज डिसएडवांटेज तो मालूम है, मैं आपको प्रैक्टिकल चीज बता रहा हूँ. So he is still using that. उसमें प्रॉब्लम क्या हो गया कि उसमें you cannot charge your mobile DC motor. So he has to put a small inverter. तो सारे जो villagers है ना, they come कि उनको मोबाइल चार्ज करना है और बिजली नहीं आ रही है. So he has to put a small inverter so that they can charge their mobile. Anyway, so let's go ahead. This is that system which I was saying that Thori has developed by putting lot of generators in series and then making a DC line and transmit the power. In fact, over the period of time, AC took over the DC altogether because the DC system simply did not work because of the convenience of stepping up, stepping down in AC, construction of the motors and things like that. But in 1929, there came mercury arc valve. Have you heard this mercury arc valve? नाम सुना है.
hydratron valve.
This पहले thyristor valve was not there. Thyristor was not there. So it is a glass valve which is having the electrodes where actually current can pass through, filled up with the mercury. So they were known as mercury arc valves, and they created a mercury arc rectifiers, rectification के लिए. So 1929, this mercury arc valves were made, and with the help of this valves, first HVDC was commissioned somewhere in 1954. Why? See, in Sweden, there is a Gotland. Gotland is an island far from the mainland Sweden. So they have to give power supply to the Gotland. How they will give? Basically, this is a almost 100 kilometers distance. In between there is a ocean. You cannot make a transmission line. Transmission line is not possible. You can only take a undersea cable. But cable has got a very high capacitance. If you put it into DC, sorry, AC cable, the capacitance will be very high. Charging current will be very high. So it was found convenient to connect it by DC, which will not have any reactive power. So necessity is the mother of inventions. You've heard this, no? Necessity is the mother of inventions. So they created a 20 megawatt monopolar link. Monopolar will come to what is the monopolar and what is the bipolar. With the help of submarine cable. So this is the first HVDC which was made with the help of mercury arc rectifiers. You're saying something?
Hydratron valve is in market.
That came subsequently. Thyristors. Thyratron, they call this as a thyratron also. Then solid state valve became this thyristor, not thyratron. Then this Gotland link was having only single pole. Single pole means plus and zero, not minus. Rather reverse. It was a minus and zero. Plus came later on. So when this plus came, what I'm saying plus means this is basically 100 kV. So minus 100 kV to 0 and then plus 100 kV to 0. So then it became bipolar link. This was done in 1970 with the help of solid state thyristor valve in place of this mercury arc rectifiers. So this is the history.
So how is it generated by connecting DC generators in series?
That was in 1912. I think आप late join किए.
No sir, this one. In 1954, how they connected by transmission DC?
वो मैं कह रहा हूँ ना, ये सिस्टम 1912 में खत्म हो गया.
After that.
हाँ.
So
ये
then
इतना
in
so much problem. They started with the DC, and when 1895 में जब ये AC system आ गया, DC system has lost its value. Edison has to sell off his company, became bankrupt, and DC systems got nowhere. They simply vanished. 1910 और 1912 के बाद DC system का कोई नाम लेने वाला दुनिया में
HVDC आपको.
क्या?
HVDC the second one.
HVDC की बात नहीं कर रहा हूँ मैं, अभी DC की बात कर रहा हूँ. ओके, अभी मैं सिर्फ हिस्ट्री पे आ रहा हूँ. विल कम टू HVDC. उस वक्त नहीं था.
This one I was talking about this one. How they
this
generated
was-
HVDC 100 kV and how they generated 100 kV.
100 kV by this mercury arc rectifiers.
Okay.
वो AC तो होना चाहिए ना.
AC से फिर
हाँ,
ठीक.
that is the only way. वो सिस्टम तो सीरीज में लगाने का 100 kV तो सिस्टम इज नॉट वर्किंग. इनिशियली रेने थ्रू स्टार्टेड विद दैट, बट दैट सिस्टम डिड नॉट वर्क.
सर एडिसन ने जो शुरू किया था एक 110 केवी वोल्टेज को
110 वोल्ट
110
वोल्ट
तो उसको सीरीज में लगाने के लिए तो लगा दिया.
हाँ.
11 केवी बना दिया.
11 kV नहीं, 110 वोल्ट.
110 वोल्ट को सीरीज में जोड़ते चले गए.
वो बाद में एडिसन स्टार्टेड विद 110 वोल्ट सिस्टम.
हाँ, तो वो जो सीरीज में जोड़ते चले गए तो सीरीज में तो ह्यूज अमाउंट ऑफ वोल्टेज ड्रॉप विल बी ऑपरेट.
वोल्टेज ड्रॉप विल बी व्हेन यू ट्रांसमिट द पावर. जब वहां पे कर रहे हैं तब तो एडअप हो गया वोल्टेज.
हाँ, वही बोल रहा हूँ.
हाँ, फिर उसमें क्या प्रॉब्लम है?
प्रॉब्लम नहीं वही बोल रहा हूँ. डीसी में ड्रॉप बहुत ज्यादा होता है.
ड्रॉप
सीरीज में जरूर लगा है.
I am not able to understand. ड्रॉप तो करंट फ्लो होगा तब होगा ना.
वो तो है, मैं वो नहीं बोल रहा हूँ.
हाँ.
पैरेलल में जैसे वोल्टेज कांस्टेंट होता है.
किसमें?
पैरेलल में.
पैरेलल में 110 विल रिमेन 110.
हाँ.
तो फिर उसको फायदा क्या है? कल की क्लास में थे आप? नहीं थे.
कल के क्लास में ऑनलाइन में अटेंड कर गया था.
ऑनलाइन में अटेंड
वो जो टावर के क्वेश्चन पूछे थे.
हाँ हाँ, तो कल के क्लास में मैंने बताया था कि व्हाई डू यू इंक्रीज द ट्रांसमिशन वोल्टेज? Because reduce the loss and reduce the current, so that losses are less. So if you create in parallel and keep the voltage at 110 only, then losses will be very high. So that is not good enough for the transmission. That is why they have to be connected in series so that voltage become high and the current is less.